Hey, I'm Tom from Bulb. Bulb is a green energy supplier. So we were founded in 2015, about 4 years ago. We were the fastest growing startup in the UK in 2018. We went from kind of about 250,000 members at the back end of 2017, and then right the way through 1 million by the end of 2018, start of 2019. We're at kind of about 1.5 million as of today, and we're about to launch internationally as well. My role at Bulb is principal platform engineer. So when Bulb was founded, and that's kind of where continuous delivery for cloud infrastructure comes in. So when Bulb was founded back in 2015, obviously at that point we didn't know how rapidly we'd grow or what would happen further down the road. So what we did was we bought some core billing software for the energy industry just off the shelf, like a vendor application, a Java monolith. That's worked great. That's kind of scaled pretty well for us over a few years, but we know that it's not going to scale much further with kind of like our strategy and ambition. We're not going to take that internationally. So we decided kind of in mid 2018, early 2018 to take that out and replace it with our own proprietary platform that uses a microservices architecture. And that's where the platform team comes in. Platform is kind of a bunch of different services that represent the core entities within an energy company. So stuff like account management, how we collate meter reads, compute consumption, bill for that consumption, and communicate about it. Each of those microservices is a Dockerized Flask app that's deployed onto Kubernetes. We're using GCP as our cloud provider. Where it started to get interesting was a bit like Andy was talking about before. We kind of got all this application code that's fairly high velocity getting shipped all the time as we build out this infrastructure, as we build up this application stack. But on the other side, we've also got a bunch of infrastructure dependencies that we also need to build. So each of those like Flask apps also has a relational backend. We've got kind of got Postgres running. And the question came like, how did we unblock our developers from having to wait for the infrastructure deployments to happen and empower them to actually just go deploy that infrastructure themselves? So we landed on Terraform and continuous delivery of that Terraform using CircleCI. So CircleCI is like a managed CD pipeline that we use at Bulb. And what I wanted to do today was kind of demonstrate some of those principles and how that might actually work in practice. So I haven't got too many more slides. I've only got 2 slides. I have a title slide and an architecture slide, which we'll look at in a second. So I was like, what convoluted example can I think of to demonstrate some of these principles and over-engineer things a little bit so we can actually look at some code, look at some Terraform modules, and look at a CircleCI pipeline without giving away too much information about how Bulb Stacks is working. And one of the things I've seen a little bit lately is Netlify. Anyone using Netlify at the moment? Yeah, it's really cool, isn't it? Yeah. He's nodding, you can't see that, but I can. So Netlify is like a really awesome way of deploying static sites really quickly. You kind of basically spin up a repo in GitHub or some other like hosted GitHub provider, Git provider, and then kind of wire that in with a CD pipeline, push your HTML, and then it'll just go get deployed. It happens in seconds, which is like really cool. It just uses webhooks into the hook to go handle that. I was like, how could I build a similar sort of thing in Terraform? Just in a little bit more detail, the other thing that Netlify pushes is this thing called Jamstack, which is JavaScript, APIs, and markup. It was a little bit vague what Jamstack was, so I found this website called jamstack.wtf usefully. They've got this really handy architecture diagram here, which makes it no clearer at all to me exactly what it is. JavaScript APIs markup. Basically, it's JavaScript on the front end and then probably some serverless backend. So rather than having kind of maybe a Kubernetes cluster deployed behind your site and that running a bunch of services for your backend, instead you're probably using AWS Lambdas or Cloud Functions. They act as a gateway, and then you probably farm out all your requests to third-party services like Stripe or something like that. So cool. So what can we build to demonstrate some of these principles? So just going back to this slide, this is the equivalent of Netlify as a bunch of, the architecture. So we're going to start with a HTTPS forwarding rule. That hits a target proxy, which terminates the HTTPS connection. From there, we resolve via a URL map to our backend services. In this case, because it's a static site, we're just using GCS bucket. Bulb is a Google shop front to back, so we're not using AWS, we're on GCP. For HTTP connections, we want to redirect those to HTTPS each time. To do that, we could do that in a CDN like Cloudflare or something. But instead, we're just going to write a small HTTP to HTTPS forwarding service. So again, we'll forward that to a HTTP redirect service, which is just an Nginx server basically on the front end. It'll just forward everything onwards. So let's go to VS Code at this point. Cool, so this is the project that demonstrates that. So how many people are using Terraform at the moment? Quite a lot of people, so you're fairly familiar with it at that point in time. How many people are using it in production? Cool, cool, that's really cool. Okay, how many have like a CD pipeline wired in to deploy the Terraform? Oh shit, okay. Okay, so quite a few of you should probably be here already. But let's talk through some of those principles anyway. Actually, an interesting one, how many people have tried to refactor Terraform code? Okay, a lot of smart wide smiles at that point in time. It's pretty difficult. Cool, so let's have a look at the structure of our repo. Whoops. Okay. Hopefully that's fairly clear. So this is the repo that kind of demonstrates some of those principles I talked about. So Andy mentioned a little bit about having reusable Terraform modules that just go do one thing well within your cluster. So Terraform is really difficult to refactor. So you kind of want to keep like a bit like an object-oriented design principles. You kind of want to encapsulate the things that change. And going back to kind of like our architecture diagram that we were looking through before, we can see roughly like what might change in this design. So probably the forwarding rules and the target proxy are fairly static.
Then you can walk around if you want.
Okay. Oh no, it's all right. I'll probably loiter there as long as it's okay. Cool. But we know that the URL maps like to change as we add more backend services. No longer host our site in a storage bucket. Instead, maybe have a React app running somewhere on Kubernetes or something similar to that. On the flip side, the HTTP forwarding rule and the kind of HTTP redirect that's running under the hood is unlikely to change that much. So maybe kind of like a higher level abstraction or a Terraform module that collates all the resources together to handle that might be quite useful because we can deploy it in different places. And that's kind of like the layout that we end up with here. So if you look kind of like at the module subdirectory, we have a managed instance group module which goes in. Sorry? Zoom in a bit. Yeah, sure. Whoop. A little bit better. Yeah. Cool. So we have 5 different modules. One defines the VPC, one defines the GCP project itself. So in GCP, projects are where you kind of collate all your different cloud resources, like your VPC definition, your Kubernetes clusters, your Postgres, and so on. We have a module which defines a managed instance group. So that's how you can, from a VM template, go and deploy a fleet of VMs based on that template and auto-scale them up and down based on some core like resource consumption metric like CPU or memory consumption. We have the front-end load balancer, which handles HTTP or HTTPS termination, as we talked a bit about before. DNS zone, which manages all of our DNS records, and then a backend which defines our GCS bucket. Outside of the modules, we know that we need to go assemble those modules together, like compose them into something, and then configure them. To do that, we have a subdirectory called projects. So typically what we have is kind of like hub and spoke projects at Bulb. So we have a core GCP project which hosts the VPC, and then we have satellite projects which are associated with that. Those satellite projects have no control over the network that's managed centrally, but they are kind of allow us to provide more autonomy to individual teams within the firm. So rather than having kind of one GCP project where everyone deploys, Instead, we have several, one for each team, and they might be configured in slightly different ways, and we can set the permissions separately in each one of those projects. In this case, I only need a single project called core, as I said, which just assembles all of the Terraform modules. We can have a look at what that looks like in Terraform. So here's our module instances, fairly reusable. So we kind of got the project one. Off the back of the project, we go configure the DNS zone, the VPC, add the backend, HTTP redirect service, and the front end, as we discussed before. Lastly, the last subdirectory is the environment subdirectory. So one of the things we have at Bulb is kind of a tiered environment structure. So we have dedicated environments for dev, staging, and production. Our CD pipeline for all of our infrastructure goes and deploys into dev. We check that everything works. Then we have an approval step, which goes and then releases into staging and then into prod and so on. We can deploy our application code in exactly the same way and following the same pattern. To lay out a new environment, again, it's just a main Terraform module, and then that's the entry point for all of our code. So we can just have a look at that. So this is the kind of core project definition. That treats the project subdirectory that we talked about before as a single module, and then just goes and configures it with some of the environment variables that need to be set. It also defines where the backend sits for Terraform. So if you haven't used Terraform that much, one of the things about it is your state file needs to be stored somewhere. Basically, the way in which Terraform works is that you have your infrastructure state as defined in your Terraform code, but you also can go out and when you run some steps called Terraform plan and apply, you go requery all of the cloud provider APIs. It goes and generates a JSON file based on the results of all of those queries, assembles that into a rough view of what it thinks your infrastructure should look like, and then diffs that versus your code base. Based on the difference between that JSON object and what your code has defined, it then works out the change set that it needs to deploy. Terraform's a really cool technology as well. It works out the relationship between all of your resources. So it's actually under the hood building a directed acyclic graph based on the relationships between the different resources that you have. So for example, we know that all of our compute instances are attached to our VPC network. So if we go and change the configuration of our VPC, it's actually going to go tear down all of our GCE instances at that point in time and reassemble them. Cool. So that is the production environment deployment. So how do we go about getting this deployed via CD? So we use CircleCI internally at Bulb. CircleCI is kind of, as I said at the start, is a SaaS which provides you a continuous delivery pipeline. Our lever for configuring CircleCI is something called a config.yaml file. We have one in every single repo. In this case, we've got one in an infrastructure repo. The way in which CircleCI works is it's kind of got an object hierarchy. At the top level of that hierarchy are commands, which kind of like map to bash commands. In this case, you can see one for Terraform init. Commands are composed of steps, Terraform init again, or Terraform plan. You might need to go get some credentials or something like that, or attach and build a workspace. Commands themselves are composed into jobs, and jobs are composed into workflows. That means you can kind of have repeatable units of work. So one of the nice things is your kind of CD pipeline is nice and dry, so you don't have to repeat yourself too much. You can have a job which goes and defines Terraform like plan or apply, but you can change the subdirectory, which will just change the kind of target set configuration that goes and gets deployed in each environment. If we look at that in a little bit more detail, here's our workflow down the bottom. This is our infra pipeline. So we've got something which goes and checks out our source code, runs the plan. The plan step only works to the point at which the validation's passed. So the validation's running static analysis on the Terraform code and also checking the formatting to make sure everything's nice and neat. We run the plan, we hold it on a manual step for the approval to make sure that someone agrees with the change set that's actually going to go and get deployed. Then we run Terraform apply off the back of that. When we assemble all those things together, we end up with again, a directed acyclic graph that looks a little bit like these steps here. And I ran this at the back end of last week, so you can see each one's completed fairly quickly. That's about it. That's everything I wanted to show.